Given this equation, x minus 5 raised to the power of logarithm of 5x minus 25 equals 2, then the goal is to find the numerical value or values of x that satisfies this equation. Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Alright, so given this equation, x minus 5 raised to the power of logarithm of 5x minus 25 equals 2, then the goal, of course, is to solve for the value of x. Now, one thing to notice here is this 5x minus 25. Because take note, we can factor out 5 in these two terms. So the common factor is 5. If we do that, we have 5 multiplied by x minus 5. Now, as you can see, we have two terms that is similar. And if we have this kind of situation, what we're going to do is to replace this with another variable. And now let's call this as n. Now our equation becomes n raised to the power of logarithm of 5n equals 2. So now this equation looks simple than before. And then what we're going to do here is to get the logarithm on both sides, because we will use some laws of logarithm. Now, before that, let's focus on this result. And now, what we're going to do is to use some properties of logarithm. If we have logarithm of b raised to the power of a, we can rewrite this as a multiplied by logarithm of b. So our equation or term in the left hand side, we can rewrite this as logarithm of 5 times n multiplied by logarithm of n. Now, logarithm of 5n, we can rewrite this as follows. If we have logarithm of a times b, we can rewrite this as logarithm of a plus logarithm of b. This is called the product rule. So logarithm of 5 times n, we can rewrite this as logarithm of n plus logarithm of 5. Now, what we're going to do is to multiply this logarithm of n to logarithm of n and logarithm of 5. So this is just logarithm of n raised to the power of 2 plus logarithm of 5 times logarithm of n. Now let's focus now on this result. Now one thing to notice is this 5, because this 5 is 10 over 2. Now why is this important? Because we know logarithm of 10 is 1, and we have here logarithm of 2. Now, to simplify this, logarithm of 10 divided by 2, we can use another property. This is the quotient rule. So if we have logarithm of a over b, we can rewrite this as logarithm of a minus logarithm of b. So logarithm of 10 over 2, we can rewrite this as logarithm of 10 minus logarithm of 2. Now, let's focus on this result. And we know logarithm of 10, a while ago, we said that this is equal to 1. And the rest is bring down. Next, multiply 1 by logarithm of n and negative logarithm of 2 to logarithm of n, or distribute this logarithm of n. Now at this point, notice, we have here logarithm of n, we have a common factor. And if we equate this to 0, we can see that we also have a common factor of negative logarithm of 2. So now, factor out logarithm of n and factor out negative logarithm of 2. And if we do that, we get something like logarithm of n multiplied by logarithm of n plus 1, and on the other side, logarithm of n plus 1 also. So if we distribute those common factors, we get the original equation. Now, notice we have here another common factor of logarithm of n plus 1. And if we factor out this common factor, we get something like logarithm of n minus logarithm of 2. Now, since it is equal to 0, we know at least one of them must be equal to 0. So we have two possible cases. Logarithm of n plus 1 equals 0, or logarithm of n minus logarithm of 2 equals 0. Now let's solve for the value of n in the first case. First, let's subtract 1 on both sides. And let's rewrite this logarithmic equation into an exponential equation. Take note, when we have logarithm of b equals a, we can rewrite this as b equals 10 raised to the power of a. Since we don't have any base, so it is common that the base is equal to 10. That's automatic. Therefore, we can rewrite this equation as follows. we have n equals 10 raised to negative 1. And 10 raised to negative 1, we can rewrite this as 1 over 10. And this is the first value of n in this case. Now, how about on the second case? So, add logarithm of 2 on both sides. And take note, we have here both logarithm in the left and the right hand side. Therefore, we can say that n equals 2. Alright, so we found n equals 1 over 10 and n equals 2. But we don't care to the value of n because we want here is the value of x. Now we know n equals x minus 5. So let's replace all n with x minus 5. Now let's solve for the value of x. In the first case, let's add 5 on both sides. 5 plus 1 over 10, we have here 51 over 10, and that is the first value of x. Now how about on the second case? Add 5 on both sides. 5 plus 2 simply equal to 7. And that is the second value of x that satisfies this equation. Now, of course, we need to check that these two values really satisfies our equation. So let's do the checking. Now, you can pause this video right now and see this checking clearly. As you can see, if x equals 51 over 10, we get 2 equals 2. And if x equals 7, we also get 2 equals 2. Therefore, given this equation, x minus 5 raised to the power of logarithm of 5x minus 25 equals 2, then we found two real values of x that satisfies this equation. We have 51 over 10 or 7. And that is our answer to this question. And as always, we are done.